Hello everybody, welcome back to another strength materials video. This one is, I don't want to make the joke again, super easy, but we're going to go through this quickly. Superposition, we're searching up the slope and deflection table for this problem, and we have the answers right here. We just need to plug in the values to get to it. But the problem's as follows. We have a W12 by 46 made of A36 steel. So for the steel, we got the modulus of elasticity, and we have the inertia value for the member, and it wants us to find the deflection at C. So we have two different loads here. We have a moment applied at the end, and we have the point load at the center. And we just need to go through each of these individual loading cases and superimpose them together, cumulatively add them, and figure out what the deflection is at this point. So there's only one thing you really need to understand about plugging into these values in the table. This x value is going to be the point that we are interested in. So if we have a 24-foot member, we are going to be plugging in 12 feet. So let's go ahead and start with the point load here. I'm going to look at case 1, loading case 1, and we're getting the max deflection because it's at the midspan. And we have the numbers that look like this. We're plugging into this formula here. We have negative 12 kip. And then what we have the length of the member. So 12 plus 12 is going to be 24. That's foot, cube in it. And then we put that all over 48 EI. That's going to give us 3, 4, 5, 6 kip foot cubed. And that's over EI. Going downwards, obviously. And for case 2, we have what we mentioned earlier at C. I'm going to use an X value of 12 here, 12 foot. And we're simply plugging into that deflection formula right here. A little bit of a tricky one. But we're following the exact same case. The problem is just flipped, right? So we're going to be going from the pin support to the roller. And we have a moment that is following the exact same convention. So we're just going to be simply plugging in these values without messing with the signs. So you have 20,000 kip foot for that moment over here. And then we have point C at x equals 12 feet. So we're plugging in that 12 once again, 12 feet here. This is going to be over 6 EI times the length of the member. So 12 plus 12, that's going to give us 24 foot. And then the last part of the problem or the equation is going to be that L, which is 24 once again, subtracting X, which is 12. Now both of those are squared. That's going to leave us with foot squared over here. And then solving that, we're going to be left with 1800 over EI. And that is kip foot, what is this, squared? Oh, no, sorry, cubed. And now we just need to go ahead and add these both together. Super simple. So the total deflection at C will equal to case 1 deflection plus case 2 deflection, which will give us a 3, 4, 5, 6 plus 1800 over EI. This is downwards, by the way, sorry. Adding those together, we are left with 5, 2, 5, 6, and that's all over EI, right? But we're given the E and the I for this problem, so why don't we give this a try solving for that? So on top, we're going to have kip foot cubed here. Then let's see what we have in the bottom first. We have the 29, and that's 10 to the 3 KSI times 10 to the 3, and that is kip inch squared. And then the E, or the I, sorry, is 350 inch to the 4. And on top, we need that conversion for this foot cubed. So we're going to be using 1728 inch cubed over foot cubed. What does that mean? So there's 1728, 1728 inch cubed for every foot cubed. So that converts, this cancels out. This is going to turn this into a 2. And then this is going to turn this into a 1, leaving us with a final number of 0.895 inch. And that is downwards. Boom. Super easy, super simple. Once again, just using these tables to add together to get to our final values. So hope this helped. Thank you. If this video helped you, feel free to leave a like and ask any questions in the comments below. If you want more videos like this, feel free to click the links on the screen.